Hello everyone and welcome to the channel. In this video, I am going to introduce you a very fascinating project called as Generative Photo Montage. Generative Photo Montage is a framework that allows users to create their desired images by compositing multiple generated images. Their framework is flexible and can be used for various applications such as generating unseen appearance combinations, correcting shapes and removing artifacts. Let me show you in a detail. If you look at this diagram, they're trying to solve a very interesting problem. The problem is that text to image models are powerful tools for image creation, we all know that. But these models may not achieve exactly what a user envisions. For example, the prompt "a robot from the future" can map to any sample in a large space of a robot image. From the user's perspective, this process is same to a dice roll. In particular, it is often challenging to achieve a single image that includes everything the user wants. The user may like the robot from one generated result and the background in a different result. They may also like certain parts of the robot, for example, the arm in another result. The key idea which they are trying to float is again quite interesting. They have proposed a different approach. This suggests that the possibility of synthesizing the desired image by compositing it from different parts of generated image is quite workable. In their approach, users can first generate many results, which means roll the dice first and then choose exactly what they want, composite across the dice rolls. Their key idea is to treat generated images as intermediate outputs. Let users select desired parts of the generated results and then composite the user selected regions to form the final image. This approach allows users to take advantage of the model's generative capabilities while retaining fine grained control over the final results. The method, which you can see here on the screen, is quite interesting. The method takes in a stack of generated images and produces a final image based on a sparse user strokes. In the first figure at the top left in the figure A, in their image stack, images are generated normally through ControlNet. Using one or more prompt, the generated images share common spatial structures as they are produced using the same input condition. For example, edge maps or depth maps. Secondly, in the image B, upon browsing the image stack, the user selects desired objects and regions via broad brush strokes on the images. And then in these examples, the user wishes to remove the rock at the apple bite in the first image and add the red leaf from the third image. To do so, the user draws strokes on the base rock in the first image, the patch of grass in the second image, and the red leaf in the third image. Their system takes the user input and performs a multi-label graph cut optimization in self-attention feature space to find a segmentation of image regions across the stack that minimizes seams. The graph cut results is then used to form composite QKV features which are then injected into self-attention layers. The final image is a harmonious composite of the user selected regions as you can see in the final diagram. Now, they have also shared a lot of other examples in the project which you can check out. For example, this shows you an example of appearance mixing where they have shown applications in creative and artistic design where users refine images based on subjective preference. This is useful in cases where the user may not realize what they want until they see it. For example, creative exploration. If you look at this example of shape and artifacts correction, while users can provide a sketch to guide ControlNet's output, ControlNet may fail to adhere to the user's input condition, especially when asked to generate objects with uncommon shapes. In such cases, their methods can be used to correct object shapes and scene layouts given a replaceable image patch within the stack. If you look at this example, this shows you prompt alignment because in addition, generative photo montage can be used to increase prompt alignment in cases where the generated output does not accurately follow the input prompt. For example, it is difficult for ControlNet to follow all aspects of long complicated prompts. Using their method, users can create the desired image by breaking it up into smaller prompts and selectively combining the outputs. If you look at this example about qualitative comparisons, you will see that they have compared it with various existing works. And in this comparison, they have shown that their method and related works. In interactive digital photo montage, pixel space graph cut may cause seams to fall on undesired edges, and their gradient domain blending in general does not preserve color. The birds, for example, if you look here, the bird's yellow beak is not preserved in the F1. Blended latent diffusion and MESA control plus control net may also lead to color changes and structural changes, as you can see in the ABCD. There are also few limitations too, which is good that they have mentioned it, because their method assumes some spatial consistency among images in the stack. In cases where the images differ significantly in scene structure, their method may produce semantically incorrect outputs. For example, in the figure A, two images have different horizons in the background. Naively combining two halves of the image leads to an inconsistent horizon. Users can manually designate a consistent horizon by selecting the background of second image. Alternatively, as in figure B, users can add a horizon in the input sketch to ControlNet to make it consistent across both images. So all in all, looks like a real fun project to me. And the good thing is that they have discussed a lot of details there. And one more thing is that uh, in all the examples, they have shown real world images, which is quite good. For example, in this one, the current graph cut parameters are empirically chosen to encourage congruous regions, which penalizes seam circumference. While this works well for many cases, if the target object has a curvy outline, it may require additional user strokes to obtain a finer boundary. So, since graph cut solves in near real time, users can quickly check the graph cut result by visualizing it in image space and iterate as needed. So, all in all, I would say that great stuff by the researchers. I will drop the link to this paper in video description. Read through it. Let me know what do you think. I think one of the good projects I have seen so far. They also have shared a repo and stuff, but I think still project in making. So I will keep an eye, and I will also do a hands-on video once it is fully prepared. I hope that you liked it. If you did, please consider subscribing to the channel. If you're already subscribed, please share it among your network as it helps a lot. Thanks for watching.